Hi, today I'm going to teach you the upside down birthday cake method for finding the GCF and the LCM of two numbers. The first thing we want to do is think about factors. I always like to think about Factor Fairy. Factor Fairy is really small. She's a little tiny fairy. So our factors are going to wind up either smaller than or equal to one of our numbers that we're working with today. Generally, if it is equal, it's going to be the smaller number. Okay, so the first thing I need to do is put my two numbers into a layer of birthday cake. And that's going to look something like this. Okay, the next thing I do is I think, what number could I divide out of both of my terms in my layer of birthday cake? The first one I always try to start with is 2. And since these are both even numbers, 2 will work. So I'm going to put my number that I divided out in front. 12 divided by 2 is going to leave me with 6. I can also think about it backwards. 6 times 2 would be 12. Okay. 36 divided by 2 will leave me with 18. Okay, now I move down and I think, can I still divide a factor out of one of these two numbers? And the answer is yes. So I put down another layer of birthday cake and I think, what could I divide out of both of those numbers? And the first number that comes to my mind is 3. Both of those numbers are divisible by 3. So 6 divided by 3 will leave me with 2, and 2 times 3 is 6. I can check it and know that I'm right. 18 divided by 3 is 6. All right, so I think again, can I divide a factor out of both of those numbers? Are they divisible by another number? And the answer is yes. They're still both divisible by 2. So 2 divided by 2 is going to leave me with 1. And 6 divided by 2 is going to leave me with 3. I can check it using multiplication. Since 1 times 2 is 2 and 3 times 2 is 6, I know that I've done it correctly. So the last thing that I have to think about here is, can I divide 1 and 3 by another number other than 1? And the answer is no, because they're both prime numbers, meaning that they're only divisible by 1 and themselves. I cannot divide them any further. So now what I want to do is go back to my thought of that Factor Fairy. Remember Factor Fairy, here she is, she's tiny. She's like a little butterfly, kinda. She's really small. And what I'm also going to focus on is the F's in Factor Fairy, because what I want to do is take what I've done here, my birthday cake, and make an F for Factor Fairy. And see how she has wings over here? What I'm going to focus on is the numbers in her wing. You see that? See the numbers in her wing? Since I've used division to pull these factors out, in order to create the greatest common factor, I have to take all of those numbers and multiply them together to get my GCF, my greatest common factor. So the numbers in her wings are 2, 3, and 2. I multiply 2 times 3 and I get 6. 6 times 2 is going to give me my answer, which is 12. So let's think. Did our greatest common factor turn out to be smaller than or equal to our smallest number that we were working with? And the answer is yes. It was equivalent to 12, which was our smallest term. Okay, so that's how you can use the upside down birthday cake method to find the greatest common factor. Now I want to show you how to use that same method to find the least common multiple. Okay, it's similar, but you're just going to create a little bit of a different shape to find your answer. When you think about least common multiple, I want you to think about multiple monster. Rah, multiple monster. He's really big and scary. He's big. Okay? So multiples, since we use multiplication to create them, those numbers, instead of factor fairy getting smaller, that multiple is going to be bigger, right? It's going to be bigger than either one of these terms that we started out with, okay? So I want you to keep that in mind. All right, so what we're going to do is I have this already done the way that we did it over here with the upside down birthday cake, same exact thing, okay? So our factoring works exactly the same, only this time what we're going to do is we're going to focus on the L for the least common multiple, or some of my students last year like to think about it as the boot of the monster. Doesn't this, when you circle it, doesn't it kind of look like the monster's boot? You can give him like a little sock up here if you want, and here's his toe. Okay? So what we do is we take all of those numbers, and can you guess it? Guess what we did over here. Do you remember? Yep, you guessed it. We're going to multiply them, just like we did before over with the factors, except for this time we have a few more numbers to add in to our multiplication. So 2 times 3 is going to give me 6. 6 times 2 will give me 12. 12 times 1 is just 12. And 12 times 3 is going to give me my final answer of 36. So my LCM will be 36. Now let's think about it. Did our least common multiple wind up to be greater than or equivalent to our greatest number that we were working with in the beginning? And the answer is yes. So that's how you can use the upside down birthday cake to find both the greatest common factor and the least common multiple of two numbers.